So hello everyone. We are now going to study about a component-based software development. It incorporates many characteristics of spiral model. That is, it is evolutionary in nature, by which we mean that it has an iterative approach, and each iteration it creates a more enhanced version of the software. At the same time, this model also has uses a pre-packaged software components. That means this why it uses a pre-packaged software component. It uses a pre-packaged software component in order to have two basic things. One is it wants to cut down the cost of like in term of time. We want to create system which can be developed fast in the comparison to the other piece of softwares. And at the same time I want to have a standardization across the software development. Okay, the tool that I use should be the same as somebody else can use, so that there will be certain set of standardization that will be part of the software development. So we use these pre-packaged software components. The next thing is these pre-packaged software components are called as commercial off-the-shelf, the COTS software components. Commercial means they are made for commercial purpose, and off-the-shelf generally means because these are a package that you haven't created, you are just using it. So that's why they are known as commercial off-the-shelf software components. They are developed by vendors who offer them as products. So somebody develop a package and we can incorporate that package in our particular software. It is known as COTS, commercial off-the-shelf components. Regardless of the technology that is used to create these components, the component base of development incorporate the following steps. First thing is, whatever technology you use, when we decide to go with component based system, we need to take care some of the points. The first thing is, available component based products are researched and evaluated for the application domain in question. So we want to find out what are the components that we can incorporate, or we can use, or we can import in our particular system, in our particular domain. So you cannot use the same package in insurance domain as you are using in banking domain, or even if you are using in any other domain. Okay, so for each domain the package that you are going to utilize might be different. Might be they are same across lots of packages. There are some inline packages, likewise you are using it in all the domains, but some packages are specific to the domain itself. So we will find out the packages which are inline or which are specific to our domain. Secondly, all component integration issues are considered. So we will consider that when we are going to integrate this, what issues it can generate and how we are going to overcome those issues. Third, a software architecture is designed to accommodate the component. Now, we have found out what component we need, and we have also analyzed what are the integration issues, and we have resolved those issues. We know the how we are going to overcome those issues. We now want to create an architecture, or we want to place that component in our system at a right place to integrate it with our own system. Components are integrated into blocks. Now once we are done with this designing part, we are now integrating that component in our particular system, and then we do a comprehensive testing to ensure that it works properly. It doesn't affect the original functionality of the system which was there without the package, without the component, and it actually gives out its own functionality. So these are the basic points that we need to consider when we are choosing a particular component for a component based software development. So this is a model. This is the component assembly model. It will, the first thing is identify the candidate components. So it finds out what all components are required for our particular domain. Then it looks up in the library. So it says that I will check whether such component is present into my product repository or product database or product uh, warehouse. So it finds out whether the components are actually available there. If it is not, if it is, then I will extract the component and construct the systems, right? I will extract, or you can import the component or package or module, and then you will create your own system. If it is not available, I will have to build the component, or actually I have to purchase the COTS, and then I will actually construct the system. At the same time, I'm going to update this library with that component, so the next time somebody else come up, he actually finds that component and he actually uses the component. Okay, this is how it actually works. So the main characteristic of the component based software engineering is it makes intensive use of existing reusable components. So the component that is created by someone else, we can reuse it in our case, and this will reduce extensively the time of software development. The focus is on integrating the components rather than on creating them from scratch. So my focus is to integrate this component rather than creating them from the scratch, so that I can do away with my work with lesser amount of time. So the advantages is it reduces considerably the software development, that is in-house development. That means in-house means you develop it from scratch, allows faster delivery, in principle more reliable system due to using previously tested components. So the component that is already tested, already running somewhere else, you have incorporated those components. We are not choosing anything which is not tested. So these components are actually in use, they are in production, they are in with the clients, clients are using it, so we incorporate them in our system. So we are trusted, we are sure that they won't fail, right? At the same time, it also has certain disadvantages. The first thing is it compromises the requirements are needed, less control over systems evolution. So once the component, you buy the component and you integrate it in the system, it is very less chance the system may fail. This is a positive aspect. But if the system fails, you have no other option to replace the component. You cannot go and modify the system. But COTS come with various versions. It says that sometimes you buy a component and you use it, and once the system fails, you buy another one and use it. Okay. The second option is you buy the component and you hire a team from that company to overcome all the issues. Whenever there's an issue, you raise it to that particular company. The company fix the issues and your system start working again. The third option is you buy the component, you take the help from the existing company, and after a bit of time, you take over your own team to work on the components. So in that way, you make your own team reliable enough to fix all the issues. So it depends upon what level of control you want in evolution. So this last point actually is a general description that I don't have less control. Yes, when I don't study the component, I don't have knowledge about the component, I don't have control over the evolution. But if I have buy the component, I have my team ready, the team learns it and it knows architecture of the component, it can enhance also. When there is a pool of existing components that could satisfy the requirements of a new product, so I can use it. And emerging trends, integration of web service from the range of suppliers. So you want to integrate multiple suppliers using multiple web services. So you can use multiple type of web services like SOAP and another thing to integrate more and more clients to your own system. So this was about component based model. In the next, we are going to see about a very short video about process models. Okay, thank you very much.